Homework help video for Advanced Algebra, Chapter 13, Section 4. We're going to look at 4 problems. The first being number 18, asks you to find the area. We have an equation that allows us to find the area of a triangle. Area of a triangle is equal to 1/2 times 2 side lengths and the included angle. So what that looks like, if this is angle A, B, C, there's my 136-degree angle. Side A, 3 meters, side B, 4 meters. The angle is between the two sides that I'm given. So I can use that formula, plug in my side lengths of 3 and 4 times the sine of the 136-degree angle. And I can go through, I can type it in my calculator all at once. I can do it in pieces. What you do want to be careful of is that your calculator is in degrees for the angle. If you're in radian mode, you're going to get something completely different. I take 6 times the sine of 136, and I get 4.168. So I'll say my area is about 4.2 square meters. There's my area. Second question we're going to look at is question number 20. Question number 20 says, solve the triangle. Solve the triangle means find all the angles and all the side lengths. Well, if I take a look at my triangle, they gave me a 62 and a 17-degree angle. I can find angle B without too much pain. Angle B will be equal to 180 degrees minus the 62 minus the 17. So angle B is 101 degrees. All right, I got all my angles. Now I need to find my side lengths. Well, my two side lengths are side C and side B. I'm going to find C first. No special reason, just M. To find side C, I can use the law of sines. Right, how does the law of sines work? I take the sine of an angle, say like A, which would be 17 degrees, divided by the side across from it, so side A, which is 1. That ratio will be equal to the sine of any other angle and the side across from it. So for instance, if I want to find side C, I could take the sine of 62 and divide by side C. The sine of an angle divided by the side across from it. Those ratios will be equal in a triangle. So I have it set up. I have 3 numbers and a variable. I can cross multiply and divide. Sine of 62 times 1 divided by the sine of 17, and I'll have side C. And side C, if I do that on my calculator, will be about 3.02 units long. I don't have a label anywhere, so at least not that I copy down. So I got side C, I need side B. This is not a right triangle, so I have to use trig. I have to use that law of sines again. I can reuse the first ratio. It's supposed to say sine of 17. Let's try that again. Over 1. And this time, I want to use angle B. So that would be the sine of 101 over the side across from it. Sine of an angle over the side across from it. Again, I can cross multiply and divide. Sine of 101 divided by 1 times the sine of 17. And I got B. Side B is approximately 3.4 units. And between the two side lengths and the angle, I have solved the triangle. I found all the missing pieces. Our next question is going to be number 30. Number 30 says, determine the number of solutions, then solve the triangle. when you are given this type of scenario, I'm given two sides and an angle, two sides and a non-included angle. I want to make sure that I can actually have a triangle to begin with, and possibly I could have two different triangles. So if I start by drawing a picture of what I was given, there's angle A, angle B, angle C. I'm told this one is 33 degrees, side A is 2, side B is 3.5. Two sides and a non-included angle. I could possibly have 0, 1, or 2 different triangles. So I want to see if this is even possible. Okay, so how can I decide? Well, I could start by, say, finding angle B. How? Using the law of sines. Just talked about that in the previous problem. I can take the sine of an angle and divide it by the side across from it. That will be equal to the sine of a different angle, say angle B, over the side across from it. Say that's 3.5. And now again I can cross multiply, divide. So 3.5 times the sine of 33 divided by 2, and I'll get the sine of B. So if I do that on my calculator, I'll get the sine of B is equal to 0.953, or thereabouts. That's supposed to be a 9. I need angle B, so I'll use the inverse. To find angle B on my calculator, I'll type in the inverse of that decimal that's on my screen. And I'll get angle B to be about 72 degrees. Well, if angle B is 72 degrees, I can use that along with the 33 degrees from angle A to find angle C. I do 180 minus 33 minus 72, and angle C is about 75 degrees. Well, the only thing I have to figure out now is side C. I found angle B, I found angle C. All three angles have to 180, so I got to see if I can find how long side C is. Well, I'll use the law of sines again. I'll reuse that first ratio. That's sine of 33 over 2. But this time, I'll take the sine of 75, angle C, over side C. I'll cross multiply sine of 75 times 2 divided by the sine of 33. I'll get side C to be about 3.5 units long. I don't recall if there was a label there or not. Now that's just one. I was able to create one triangle from this information. I now have to see if it's possible to create a second triangle. All right, so all this is for triangle number 1. If there is triangle number 2, my original picture stays the same, but if there is two solutions, remember I started by finding angle B? If there are two solutions, angle B would equal, or is the supplement. So 180 minus 72. If there are two triangles, angle B is going to be equal to 108. 72, in case you're forgetting, 72 came from there. Right now, if I think about my triangle, I have the 33 degree angle from angle A. I'm now saying angle B is 108. those two together allow me to find angle C. Angle C, 39 degrees, 180 minus 108 minus 33. So I already have two possible angles. Again, I have to find side C. I'll use the law of sines again. I'll take that first ratio, sine of 33 divided by 2. You can reuse that one over and over again. But this time, angle C is 39. So I'll take the sine of 39 divided by side C. I'll cross multiply and divide. Sine of 39 times 2 divided by the sine of 33. And I'll have side C. And side C is approximately 2.3 units. So I have two different sets of answers. I have the one in blue and green. That's one possible triangle. And I have the one in black. The one in black, I have my two angles. And I have my missing side. That's called the ambiguous case, when you could have two different triangles based on the information that you're given. Last problem we're going to look at is number 40. Number 40 is about the hot air balloon, and I've kind of drawn the picture and I've put some labels so we can kind of look at the same picture without me trying to draw a balloon anywhere. We're supposed to figure out how high is the hot air balloon off the ground. Well, the first thing that I know that you got to be able to understand from the picture is that when they have that 64 degrees, that 64 degrees is angle ABF. So where I'm putting the blue arc is 64 degrees. Maybe a little unclear from the picture. All right, once I understand that, the second thing that we got to recognize, then if that blue arc is 64 degrees, I can find the green one by doing 90 minus 64, and I'll figure out that the green angle is 26 degrees. Next thing I can do is figure out or recognize that my angle of depression is the same as my angle of elevation. What I mean by that is they told you up here this is a 7-degree angle where I'm putting the red arc. That's my angle of depression. Over here by S is my angle of elevation. That's also 7 degrees. So the only thing now that I don't have angles for as far as triangles is right in the middle where I'm going to put a double blue arc. I'd like to know that angle right there. Well, I have everything else that I need. I have the 7-degree red arc. I got the 26-degree red arc. I know that angle ABD is 90 degrees. So I can do some subtraction here. And I can say that angle in the middle here, that double blue arc, 57 degrees. Okay. So what do I want to start by finding? Well, the first thing I'd like to find, or I can find, is I can find x. X is the distance from F to B, if you can't tell from my picture. So how do I find x? Well, use the law of sines. I'll say the sine of 57 over 5,280, that's 1 mile, is equal to the sine of 7, this is the red 7, over x. And I'll do cross multiplying and dividing. Sine of 7 times 5,280 divided by the sine of 57, and I'll have x to be about 767.25 feet. Okay, well now what? Well, now I'm going to take my answer from x and try to work something with f. You notice I just wrote the f. The little f is the height of the balloon from B what I said is D, from the balloon down. That's how high the balloon is off the ground. Now, in order to do that, I could do more law of sines. But what I recognized is, well, I could do just regular trig. So I could think to myself, so, toa. Well, what do we know? Well, I know the green 26-degree angle. I know the x in here, which I'm putting in green, maybe you can see, is 767.25. That's the hypotenuse of this right triangle. See the right triangle that I'm putting in green? So I know the hypotenuse, I have an angle, and that f, that little f that I'm trying to find, that's my adjacent leg. So what could I set up? Which one should I use? I could use cosine. I could say the cosine of 26 is equal to the adjacent leg, which I'm calling f, over the hypotenuse, 767.25. I could solve for f. If it helps, have those equal fractions again, cross multiply and divide. 767.25 times the cosine of 26 divided by 1, and I have f. And f, on my calculator, if I round to the nearest foot, should be 690 feet. There's the height of the balloon.